write in English the subject for today is adding and subtracting algebraic fractions. Okay, so let's remind ourselves what algebraic fractions are, just to remember what are we talking about. So algebraic fraction is a fraction which is built out of polynomials. So in the numerator and in the denominator, so the top number and the bottom number, we have both polynomials. So w of x and p of x are polynomials. All right, and because we cannot have 0 in the denominator, so in the bottom of the fraction, so we have to put here another very important information, that this polynomial, so p of x, cannot be 0. And that is why we spent 2 hours calculating the main of the algebraic fraction. So every algebraic fraction has the main, right? So we need to always check if the bottom, so the denominator of the fraction, if it can be 0 or not. So for example, just to remember, if we have something like this, let's say 2x plus 5, this is an example of algebraic fraction. So we have polynomial in the top, polynomial in the bottom, and we have to see if this polynomial, so in the denominator, we have to check if it's possible that it can be 0. So we have to see when this polynomial is 0, right? So that's a very simple one. So that's easy to calculate that it will be 0 when x equals to 2.5. So if we have minus or negative 2.5, then we will get 0 in the bottom. So what we have to write here, that the main is r, so the real numbers, but without negative 2.5. So that's why every algebraic fraction needs to have the main. Of course, there are fractions where we will have all real numbers, and we had examples of these fractions. Very simple example is when we have quadratic function in the bottom and the delta is negative. So let me just give you some example of this. So we can have, let's say, 2x to the power of 3 plus 5x plus 1, and here we can have x squared plus 2x plus, let's say, 17. And when we consider domain here, so we need to take again denominator, and we have to check if there is any x that we can get 0 here. So what do we do here? Of course, we calculate delta. So we get 4 minus 4 times 1, because here we have 1, and times 17. And that's very easy just to notice here that this is negative. So I don't have to really calculate delta, but it is negative. That's the most important thing here. And if it is negative, what does it mean? Well, it means that this bottom number, so this quadratic function, will never be 0. So the domain will be all real numbers. So we do not have any x that will make the bottom number 0. So we don't have to worry about any number here. So this is the example when we can have all real numbers as a domain. But of course we have to check this every single time, so we have to check the bottom number if it can be 0. Alright, what else have we done so far? Well, except domain. So the first thing was to calculate domain, and the second thing that we were doing this week was factorizing. Let's say algebraic fraction, but to be fractions, to be precise, we factorize the polynomials in the algebraic fractions, right? So what we can do with fraction, we can cancel them down or just simplify them, right? So we can, let's say, simplify, or we can say cancel down. And in order to do this, we need to factorize polynomials. So we can, let me just put here extra words like factorizing polynomials in algebraic fractions, just to be precise. So we don't, what we have to do, we have to factorize both polynomials, the top polynomial and the bottom polynomial, and then we can eventually simplify the fraction or cancel down. Should be easy here, sorry, cancel down. Okay, just a short example again. Let's just remind ourselves what we were doing. So, for example, okay, let me take quite easy. Okay, I will choose example from the book. Right, so we can take something like this: 4x cubed minus 4x squared minus 9x plus 9, and this is 2x squared minus 5x plus 3. All right, so what we want to do here, we want to simplify this fraction, so make it simpler. But to be able to do this, we have to take the top polynomial and the bottom polynomial and see if we can somehow simplify them. So the first thing we need to do is to factorize them. So make them as a product. So try to get into the brackets. So what do we do here? When we look at the top polynomial as first, let's look here. You should notice that we can group this polynomial. So we can group these two together and these two together. So let's do it. So we can have 4x squared in front of the brackets, and then what we have left is x minus 1. And from the two last algebraic expressions, we can take negative 9 in front of the brackets, and then we have x minus 1. Right, so this is how we see that we have exactly the same brackets, which is very good for us. And the bottom polynomial, I will leave it for now like this, because we need to have delta for the bottom one. So let me just finish with the top one, and then we will deal with the bottom one. So here what I'm going to do here now is take x minus 1 in front of the bigger bracket, and what I have left is 4x squared minus 9, and this is how I get a product, and this is very good for us. So what we are trying to do is to change the polynomial into the product of brackets. Okay, let me just erase this part because I need space, and I will finish it up here. Okay. this is just a like repetition, so it shouldn't be nothing new for you. But if you have any questions, of course you can ask. Right, so let me just write this one here. Okay. And now what I'm going to do, I'm going to go up and I'm going to take the bottom polynomial. So I'm going to take just the denominator, sorry. And I'm going to check when it can be 0, right? So the thing I'm going to do here, it's like really two things together. Because first, I will try to make a product out of this polynomial. And second, it will help me to write domain, because we still have to write domain. It's very important. So let's put D here, because we need to write domain for this fraction. But still, I don't have zeros of this polynomial. So let us calculate delta 25 minus 4 times 2 times 3. So it's 25 minus 24, it's 1. So it's positive delta, so it's good. Square root of delta is 1. So we get 5 minus square root of delta divided by 2 times 2, so 4. So we have 4 divided by 4, it's 1. It's the first 0. Let's calculate the second 0. So it's 6 divided by 4. And we get 3 over 2. Right, so now we can write domain, because now we know that we have to get out of the domain these two numbers. So we have to take 1 and 3 over 2. Okay, so let me just change the color. So we have the top polynomial expressed in brackets, and we have the bottom polynomial also, we can express it in brackets. So what I'm going to do now here, let's go back to the polynomials. So we have the top, so numerator, and in the bottom we get 2 times x minus 1, because we have this 0, and the second 0 is 3 halves, so it's 3 minus 3 halves. Right, and now we have domain, so we can cancel down the fractions, so we can cross these two out. And let's see what we can do more, because we have to be sure that we have done all that we can. So let's look at this bracket, and you should notice that we can still do something with this bracket, because we can write it as 2x minus 3 and 2x plus 3, because we have here formula for squared. And here I can calculate 2 times this bracket, and I'm going to get 2x minus 3. And as you can see, we can cross out these two. And what we get in the end is a very simple polynomial as 2x plus 3. So very simple one, especially if you look here. So that was our beginning. And at the end, we get this one. Right, and the whole process that we did here is called simplifying fraction or cancelling down fraction. You can call it this way or that way. It means more or less the same. And this is what we were doing for the last 3 hours, last 3 lessons. Okay, so that was just the repetition of all that we did about algebraic fractions. But today we want to do something more. So we want to learn another thing that we can do with algebraic fractions, and it's simply adding and subtracting. So before we go to adding, subtracting of algebraic fractions, yep, of course. Dzięki, Paweł. Sobie zapisuję. Okay, so let's just remember what is adding and Aha. Tak. Tutaj? Ok, znaczy tak, po pierwsze to nie jest minus 2, zobacz, bo to jest równa się. To jest dwójka. Natomiast skąd się bierze? Stąd. Jak rozkładamy funkcję kwadratową, to potem jak robimy te nawiasy z pierwiastkami, to zawsze ten współczynnik dajemy do przodu. Często o tym się zapomina, bo często mamy x kwadrat i wtedy nie musisz tu nic pisać, ale jeżeli jest tu liczba, to trzeba ją dać przed nawiasami. No a potem jedynka to jest ten pierwiastek, odejmujemy, tak? I... tam jest na plusie, tak, tak. Dobra, ok. Proszę.
Może Pani cofnąć na sekundę? Proszę.
Dobra. No tutaj to
Pani, ja bardzo przepraszam, ale
kilka razy
właśnie
tam
Dziękuję bardzo.
zaznaczam, tak? No trzeba pamiętać, bo rzeczywiście jak się robi często z x kwadrat, no to jest jedynka, jedynka, jedynka i potem właśnie dużo osób zapomina, że jednak trzeba pamiętać, że ten współczynnik on musi być, musi zostać, nawet jak rozłożymy w postaci ilości.
Pani, ja mam jeszcze jedną rzecz, czy może Pani cofnąć na chwilę?
So we have adding, subtracting of fractions.
Bo ja za bardzo nie widzę skąd na dole się, jak już jest przekształcony to wyrażenie, zamiast minus 2 przed x minus 1 i x minus 3 drugie. To za bardzo nie wiem skąd się wzięło.
In primary school, so
Po 2.
I'm sure you remember it very well. So what we have to do, we need to have the same denominator, right? So that's what we need to have, the same denominator. So in Polish we have ten sam mianownik. Right, so what we did, so we need to get the same denominator, and to get the same denominator, we have to multiply, like, let me just write everything very, very carefully. I know that most of us do it very quickly, but today we will need it to know exactly how it goes to go to algebraic fractions. So what we do exactly, we multiply by 3, the top and the bottom, and then we take 1/3 and we multiply by 2 just to get here 6 and here 6. So then we have 3/6 plus 2/6, and we have 5/6 or 5/6. So this is how we have all the procedure, the procedure of adding two fractions with different denominator. Because of course when we have the same denominator, that's easy, we just add the top numbers and that's easy, right? So if we have 2/15 plus, let's say, 7/15, so what we do, we just add these two top numbers, so we have 9/15, and then we can cancel down, so it's 3/5. So when we have the same denominator, it's very easy, right? We do not have to do much, just add the top numbers. But if we have different denominators, then we have to change them into the same denominator. I'm sure you remember this. And that's exactly the procedure that we are going to use in our algebraic fractions. It goes exactly the same, but of course we do not have simple numbers, but we will have polynomials. So that's is going to be a bit more like demanding or difficult, but the procedure is exactly the same. So what are we going to have to do is to get the same denominator and then add numerators. Okay, so let's because I don't really want to like expand on the theoretical like procedure, so you will see everything when we are going to do examples. So let me just look at the book and we will start with examples and I will explain more during calculating. Okay, so let's start with exercise 6.28. We will start with very easy ones when we have only numbers in the bottom. So let me write example A. So we have x minus 1 divided by 4 plus 2x minus 3 divided by 4. So as you can see, we start with very simple ones because we have the same denominator. It's 4 in the first fraction and in the second fraction. So that's really easy because what we have to do, we just leave 4 here, just like this example, right? So we do not do anything with the bottom, but at the top we just add them together. So it's 2x minus 3, and what we get is 3x minus 4 by 4, and that's it. There's nothing more we can do here. So when we have the same number in the bottom, that's very easy. All you have to do, you have to add the top numbers or the top polynomials, right? Because we have polynomials, so the top polynomials, right? And that's how it goes. Let's do one more here. Let's say D, the last one. It's exactly the same. So we have the same number in the bottom. So it's 2 this time, but we have something more going on in the top, because here we have formulas for multiplication, right? 3x plus 2 to the power of 2. So here we have 2, and what we have to do, well, of course, we have to multiply these two brackets, so we get 4x squared minus 1. Then we have minus here, so I will put the minus, and then I will leave for this moment the bracket, just to remember about this minus. So we have 9x squared plus 3 times 2 times 2, so we have 12x plus 4. Okay, and now we can get rid of the bracket. So we have minus 9x squared minus 12x minus 4 divided by 2. Okay, and the last thing we have to do is to do something at the top. So make order. 4 minus 9 is negative 5x squared. Then we have minus 12x and minus 5, and divided by 2. We can leave it like this. If you want to divide this expression by 2, it's also possible. So we could write it down as negative 2.5x squared minus 6x and minus 2.5. So we could write it down as one polynomial, or we can leave it like this as a fraction. Okay, so the first exercise, very easy, because we had exactly the same denominator. So let's go to the second exercise. It's 6.29, and here we have different denominators. It's still pretty easy because we have numbers in the bottom, so it's pretty good. But this time we have different numbers. So let me write the first example. It's 3 over x plus 2 plus, oh sorry, it's not this one, sorry, I looked at another exercise. Alright, so it's x minus 7 divided by 5 minus x squared plus 2 over 3 plus 2x squared minus 3x plus 7 over 15. Right. So we have 5, 3 and 15 in the bottom. So I think it's quite easy to notice that we need to have the same denominator, so it's going to be 15, right? So we do not have to change the third fraction because it is 15, so we can just write it back here for now. But we have to change the first fraction and the second fraction, right? So what we have to do with the first fraction I hope you can see that. It's just divided by 3, right? The top and the bottom. And the second fraction, to get 15, we need to multiply by 5, so the top also by 5. One more thing that you should be very careful. If you have minus here, remember to put brackets here, because this minus will change not only x squared but also 2. So we will get minus x squared and minus 2. So that's very good thing to remember, to put also brackets, always brackets here. Okay, right. So let's go. Let's multiply by 3. So we get 15. The top, we will get 3x minus 21, and now we have 15. Next one. Here we have 15, and here I will use brackets again. So I have 5x squared plus 10. Right. So now we have 15 everywhere. So we can put 15 in the bottom, and at the top we will just do all the calculations. So I hope I can make it in this space. So let's write it. The first one goes 3x minus 21. Now remember about the minus, so it's going to be minus 5x squared minus 10, right? And then we have plus 2x squared minus 3x plus 7, right? Okay, let me finish here at the top. So I will go here. Okay, and let's see how many x squared we have. Minus 5 plus 2 is minus 3x squared. Then we have this here, 3x, and we have minus 3x. So we can cross them out. We do not have to write them back. Okay, and numbers. Minus negative 21, negative 10 is negative 31, and plus 7. So we have negative 24, and divided by 15. Okay, and this one looks now very good. It looks much simpler than the first one, but still there's something we can do. I don't know if you can see that. What can we do here? Well, we can divide by 3. Because 15 divides by 3, 3 divided by 3, and 24 divides by 3. So we can divide the top and the bottom by 3. And just to write it like very nicely, what I'm going to do, I will take 3 in front of the bracket. So I have minus x squared minus 8, and in the bottom I have 3 times 5. Right, just to get the multiplication. When we have multiplication, then we can easily cross out 3, and we get minus x squared minus 8 divided by 5. And this is our answer here. Okay. Any questions so far? No, not yet. That's good. That's good. So this is how it looks. It's not very complicated in terms of calculations. It's like very simple procedure, but a lot of calculations. So you have to be very careful not to lose any number, or just be careful with minuses. But overall, it's simple procedure. Just you have to be very careful. Okay. So let me see. We can take maybe one more example here from this exercise. Right. 3, 2, 6. Okay, we can take D, the last one. Still with numbers. Okay, so it goes like this. We will have more brackets and more multiplication formula. So we have 3 minus x, 3 plus x divided by 8 minus. Here we have brackets, so it's good. They put brackets here. 4 and minus x squared plus 1 over 16. Okay,
None yet.
there it is. So we have 8, 4, 16. So the common denominator here will be, of course, 16. So what we have to do, the first fraction we have to multiply by 2, the second by 4. Okay, so let's do it. Here we have 16. In the top, at the top of this fraction, what can we do? So we can, of course, put 2 and just leave the brackets, but I am going to use the formula, okay, so that we can do it quicker. So here we have formula for multiplication, so it's 9 minus x squared. Right, so we have done. Then it's minus 16 in the bottom, and in the numerator we have 8 times x minus 1. Just to remind, please remember that if we multiply a product, you only multiply one of them. So as you can see, I only multiplied 2. So we do not multiply in the brackets. Okay, so just you do it once, not twice, because sometimes students do the mistake here. Okay, and here, right here we have the same. We can put brackets here, right, just to remember about this minus. Okay, so now we have 16 everywhere, so we can put them, all 3 fractions, in one big fraction, and we get 18 minus 2x squared minus. And now let me just multiply straight away, but remember about this minus. So it's 8x minus 8, but I have minus here, right? So it's going to be minus 8x plus 8. And then I have minus in front of the whole bracket, so it's going to be minus x squared minus 1. Okay. And now we can add the algebraic expressions. So what we have here, minus 2x squared minus x squared, so it's minus 3x squared. Then we have minus 8x, and numbers. We have 18 plus 8, 26, minus 1, 25. Hopefully we have the right answer. Let me check. Yep. Okay. That's correct. So this is our answer, and well, there's nothing more we can do here. If you wanted to divide by 16, that's not a very good idea, because then we will get fractions. So we can leave it like this. So this is the answer to adding those 3 fractions. So definitely it looks much better than this part. So this is the answer. Okay, so far we have done examples with numbers in the bottom, only numbers. But as you can predict, we will have not only numbers in the bottom, but we will also have polynomials. And we are moving to this part, and we will see how are we going to deal with fractions, different fractions with polynomials in the bottom. Okay, so if you need more time, let me know. So the next one is 6.30. And here we have examples with polynomials in the bottom. So let's see the first example. Okay, so we have, yep, of course. Okay, so we have 3 over x plus 2 plus 2 times x minus 5 over x plus 2. So we do not have numbers, as you can see in the bottom, anymore. So we have polynomials, but it's still very good. It's still very simple because we have exactly the same polynomials, right? So that's the simple version for now. Of course, later they will change a little bit, but we start with simple ones. So we have the same denominator. So what we can do, we can just straight away put them into the one big fraction, and we can add numerators, right? So we can put 3 plus 2 times x is 2x, 2 times negative 5 is negative 2, and we get 2x minus 7 divided by x plus 2. But just to be, to make it everything
Proszę
right,
pani,
we need
może
to
pani
put the
cofnąć na
main.
sekundkę.
Because we have polynomials now
Dziękuję.
in the denominator. So we just to remember, let's put exclamation mark. So we have to always look at the domain. You don't have to do it like in the beginning. So first you can do the calculations and you can write the domain later, or you can write the domain straight away if it's easy. But just remember that we always have to put the domain. Why I didn't put the domain in the previous examples? Well, as you can see, we had everywhere numbers. So when I have numbers, I do not have to put the domain because there are no restrictions. So when we have numbers, the domain is always all real numbers. So that's why I didn't put domain, because, well, of course I could put d is r, but, well, it's not that necessary. But here we have to put the domain. So we have r, but we have to exclude negative 2, because negative 2 would make 0 in the bottom, right? And this is something that we don't want to have. So that's our domain, and this is our answer. And that's all we can do here. That's our answer. So 2x minus 7 over x plus 2. So when we have the same polynomial, it's also very easy because there's really nothing much we have to do. Just add the fractions or subtract the fractions if there's minus, right? Okay, so let's take one more, maybe with minus. So let's do subtraction. 2x over 3x cubed minus 8x squared minus 4x plus 2 over the same denominator again. So we're having here the same denominator, so we can write it as a common denominator, right? And then we can just take the numerator. So we have 2x minus, so just to be on the safe side, let's put brackets. So we have minus all the numerators, so it's minus 4x minus 2. Right, and it's going to be negative 2x minus 2 divided by x to the power of 3 minus x squared. But, of course, this is not the end. I hope that you can see that too, because we can do something with the bottom. It's not the simple polynomial, it's not the prime, right? So it's not something that we cannot factorize. So if we can, we have to do it. So what can we do here? We can take x squared in front of the brackets, and we get x minus 8. the top, let's leave it as it is. Right, and now we can see if we can do something more here. Well, not really. X minus 8, we cannot do anything with x negative 2x minus 2. So this is how we're going to leave this fraction. This is going to be our answer. Right, this is all what can we do. But of course, domain, right? So again, domain. And let's look at the denominator. So when the denominator is 0, so it's 0 if x is 0 or if x is 8. So we have to get rid of those two numbers. So without 0 and without 8. I hope it's clear. If it's not, then ask a question. When we have this kind of examples, you can do it without calculation, the domain, right? I told you about this. So if it's easy, so if you can really see it from the fraction, you can write the domain straight away. You don't have to like write all the calculations. Of course you can. So of course we can write that this part, let's see when it's 0, so we know that this is 0 or this is 8, right? So this is how I get those numbers, but I hope that most of you can do this mentally, so you don't have to write it down. You can see that 0 and 8 must go out of the domain. Okay, so this is how we work. We work on the fractions which have the same denominator as a polynomial, but the same exactly polynomial. Okay, so let's try and do more complicated example. So this time we will have fractions with different denominators and different polynomials. So these examples we have at 6.31. 6.31. Okay. Let's start with A. Okay, it goes like this. X plus 3 over x minus 1 minus x plus 1 1 minus x. Okay, 1 minus x plus 2x plus 4 by 1 minus x. All right, that's it. So now we have some complications. Firstly, we have 3 fractions, not 2. So far, we had, I guess, 2 fractions always. I guess so. Maybe once we have 3. But yeah, we have 3 fractions. And if we look at the bottom, so at the denominators, we can see that we have 2 the same polynomials, but the first is a little bit different. And now what we're trying to get, we want to have the same denominator. So what can we do here to get exactly the same denominator? So what do we have to do here? Do you have any idea what can we do here? With the first one really, because the second has 1 minus x, the third has 1 minus x, so it's good for us. So how can we change the first one to get 1 minus x? Do you have any idea?
I guess do something to change the symbols. So the x is minus and the 1 is plus.
Yes, so we need to change the signs, right? The signs of the numbers. So because if somehow we will get negative and we will put like this, so negative 1 minus x, it's exactly, look, minus 1 plus x, so it's exactly this part, right? X minus 1. So what we can do, it's exactly this. So we can write this one, right, this part, as this one, because it's just, we just need to put different signs. So we need to have minus to change it. So this is how we're going to do. So the top, it's the same. And here I will write negative 1 minus x. And this is how we're going to get the same denominator. Right, very good. So, okay, what next? Because now it looks much better. We have the same, but still we have minus here. But this minus, it's not a problem. Because, why? Let me just show you here quickly. Oh, sorry. If we have something like this, so you have fraction 2 and minus 3 here. I remember
I guess do something to change the symbols, so the x is minus and the 1 is plus.
This sign, this minus, you can put like in 2 different places and it's still going to be the same fraction. So we can put this at the top, so it's the same if you take the minus and put it in the numerator, or you can put this in front of the fraction, so you can put minus 2/3. So you can have 3 options and they are all the same, but it will help you to change a little bit calculations. So this minus, we don't need this in the bottom. So what we're going to do, we're going to put this in the top. So it's going to be minus x plus 3, and then we will get 1 minus x. Okay, so, well, I have to write the rest again. A lot of writing here. Okay, plus 2x plus 4, 1 minus x. Okay. Oof, then we have the same denominator. Okay, so that's what exactly we need. So now I can put one big fraction line, I can put 1 minus x, and now we can just get the numerator. So it's minus x minus 3 minus x minus 1 plus 2x plus 4. And what we get in the end is minus x plus 2x. So it goes out. Look, cross this out. And we only stay, oh, it's minus 3 minus 1 is 0 and 4. So it's 0. 0 over 1 minus x. So it's really 0. And it's possible. There's nothing wrong here. So maybe at the beginning we cannot see that this thing is 0, but it is. Of course, we have to put the main here still. Let's not forget about the main. So it's r minus 1. Right? Because we cannot have 1 here, because then we will get 0 in the bottom. Okay, that's it. So we get 0 here. All right, so in this exercise 6.31, all the examples are about changing the sign. So we have 3 fractions, 2 of them has exactly the same denominator, 1 is a bit different. So a bit different because only if you change the sign in front of it, then you will get the second one. So all the exercise, I mean all the examples in this exercise are about the same. Okay, maybe I will give you some time just to practice, because we have done quite a lot of examples now. So let's I'll give you some time, and please try to do D. All right, I will write it here and try to do it yourselves, by yourselves, and let's see how it's going to work. I will just write it down, and just let's just look at the denominator. So as you can see, again, here's the same, here's the same. Here only change the sign. So the only thing we have to do, just put the negative, and then we have 3 minus x, and we get exactly the same. So that's what you have to do, right? And then the minus goes upstairs to the numerator, and then you add, and that's it. And remember about the brackets here, right? Not to forget about the minus. Okay, I'll give you like a few minutes, okay? And let's see if you can get the answer. And remember, of course, about the domain. If you get the answer, you can tell us, and we will check if it's okay. Dobra, dawaj Mikołaj, to ile tam wyszło? Tak, no dajmy na... Dziedzina? Dobra. Dziedzina jak najbardziej się zgadza. Czy ktoś ma inny wynik? Tak zapytam się dla jasności. Czy komuś może trochę inaczej wyszło? Dobra, ale x minus 2 masz bez nawiasu, tak? Po prostu, Szymon? Czyli tak? Dobra, nie, że minus x tutaj. Przypadkiem? Nie. Dobra, czy ktoś jeszcze jakąś inną wersję? Bo tutaj słuchaj... No właśnie, tak, to brakowało mi, dobra, to dobrze. Bo tutaj, słuchajcie, po prostu pytam o te wersje, bo mogą być w samym zapisie, bo tutaj jest minus i ten minus, tak jak przed chwilą tak pokazywałam Wam z tym zwykłym ułamkiem, ten minus może łazić sobie po ułamku, czyli może może być w liczniku, może być w mianowniku i może być z przodu. I dlatego tutaj może być tak, że każdy dostanie troszeczkę inną wersję. Tutaj obie są poprawne, bo obie są tak naprawdę takie same. Tylko właśnie
to mam
zależy właśnie co zrobimy z
wynik
minusem.
już
Czyli
wszystkiego
tak, tutaj,
podać?
no to widać chyba, nie? Co zrobił
To
Szymon.
wyszło
Czyli
mi
Mikołaj minusa
minus
zostawił, a Szymon
nawias
sobie po
2
prostu
plus x
wymnożył
zamknąć
minus
nawias
2 minus x. Więc jakby jest to
przez
samo.
3 minus x
Natomiast słuchajcie, w wyniku w książce jeszcze troszeczkę
i
inaczej znajdziecie.
r minus
Bo
3.
co oni zrobili? No to zrobili coś takiego, że jak ten minus tutaj siedzi, to oni sobie z tego wyciągnęli minusa, czyli wam pokażę, czyli w górę zostawili, tutaj wyciągamy minusa i wtedy zostaje x
Ja mam
minus 3.
x minus 2
No i wtedy te minusy,
na
tak,
3 minus x.
pamiętajmy, że minus to jest tego była jedynka, tak? Minus 1, minus 1. No to się kasuje, bo ujemny przez ujemny
Tak,
dodatnie i w książce znajdziecie taką odpowiedź.
Tak, mam.
Natomiast dlaczego ważna jest umiejętność przechodzenia między tymi minusami? No to jest bardzo ważne, bo jak będzie na przykład na maturze ABC, no to może być tak, że oni
Ania,
zapiszą taką
powinny być.
tak?
Minus x minus
Musicie
2, tak powinno być.
umieć zobaczyć, że z waszego przykładu osiągniecie tą wersję. Bo jeżeli byłoby to zadanie otwarte, no to powiedzmy spoko, tak? No doprowadziliście do jakiejś tam prostszej wersji. Jest ok, moglibyśmy to spokojnie zaliczyć. Natomiast no, ryzyko jest przy zadaniu zamkniętym, no bo oni mogą właśnie tego minusa w innym miejscu włożyć. Także tutaj jak najbardziej jest ok, tylko pamiętajcie, że właśnie z tymi minusami mogą się różne rzeczy dziać i może troszeczkę inaczej ten przykład wyglądać. Dobra, ale tak to jest wszystko ok. To ja myślę, że tutaj no mam nadzieję, że innym też wyszło. Jak nie, to sobie poprosicie chłopaków, to wam wyślę przykład. Dobra, no to mamy 6,31D. Na razie wszystkie takie są, zobaczcie, dosyć proste, nie? No bo ten mianownik dosyć łatwo znaleźć, tak, ten sam, tylko na razie minus się zmieniał, ewentualnie liczbę przemnażaliśmy, czyli na razie jest ok. No i teraz sobie przejdziemy do przykładu takiego pierwszego, gdzie już będziemy mieć takie dwa bardzo wyraźnie różne mianowniki, no i troszeczkę więcej trzeba będzie tutaj zadziałać, więc weźmiemy sobie zadanko 6,33. 6,33. Na razie 32 zostawię. Tam sobie też wrócimy jeszcze do tego. Myślę, że ile mamy 20 minut. Dobra. Ok. Okay, so let's take the first example of this exercise. So now we have two fractions with polynomials, let's see, in the bottom, and two different polynomials. Let's see, it's x plus 5 and x. So as we can compare with the previous one, so it's not about the sign right now, right? It's not enough to change just the sign. We will not get the same denominator. So now this is an example that we have to deal with it a bit different. Maybe in the beginning I will write down the main because it's very easy. So let's just write it down. It's we have to get rid of -5 and 0. Okay, so this is our domain. Right, so what do we have to do here with those fractions to get the same denominator? So what we have to do exactly the same that we did with fractions with numbers. So as you remember, 1/2 and 1/3. So what we did is times 3 times 3 times 2 times 2. So it's like we just take 3 to the first fraction and 2 to the second fraction. So it's exactly what we're going to do here. So so the first fraction we have to multiply by x, right, to get x. And the second fraction we have to multiply by x plus 5. So we just expand fractions. We can always do that. So we can expand fractions, and then in the bottom we will get exactly the same denominator. Sorry. So we will get this x plus 5 times x, and exactly the same here. X plus 5 times x. Multiplication is alternate, so I can change the order in multiplication. And what we get in at the top we have 2x, and here we have 7x plus 7 times 5, so it's 35. So plus 35. Okay, 35. Let's leave brackets. Right, and that's how we do it. We have now the same denominator. So let's put these two fractions into one fraction, and we get 2x minus 7x minus 35. And now just add these two numbers, so it's minus 5x minus 35 divided by x plus 5 times x. Okay, and that's all we can get, really, right? There's nothing we can simplify here. We could take like negative 5, but then we have x minus 7, so we cannot cancel x minus 7. So what we can do in the end, we talked about it, I think, yesterday. So that when we get to the end, we want to get algebraic fraction with polynomials. So polynomials, just to remember, they do not have brackets. Sorry, no brackets. Czyli tutaj to jeszcze przypomnę po polsku, bo to jest ważne. To mówiliśmy wczoraj, że jak dochodzimy do ostatecznego wyniku z ułamkiem, bo tu można różne wersje zostawić, tak? Możemy zostawić nawias, może tutaj ktoś by jeszcze wyciągnął -5. Natomiast w ostatecznym wyniku, jak przekształcamy ułamki algebraiczne, to chcemy mieć wielomiany na górze i na dole. I wielomiany w postaci ogólnej, czyli bez nawiasów. Więc na tej ostatecznej prostej wymnażamy wszystko, żeby nam powstały po prostu wielomiany. Czyli zostawiamy sobie -5x minus 35, a na dole wymnażamy tutaj to, czyli będzie x kwadrat plus 5x, tak? Chodzi o to, żeby po prostu były to takie, no właśnie, wielomiany w tej wersji najbardziej ogólnej. Oczywiście tutaj też mówiłam ostatnio, że to wszystko zależy, na czym polega zadanie, bo jeżeli będzie to równanie, do których my tam dążymy, po świętach będziemy robić równania wymierne, czyli właśnie równania z ułamkami, no to wtedy oczywiście będzie dla nas ważniejsza, dużo lepsza dla nas wersja iloczynowa. Natomiast na razie bawimy się samym przekształcaniem tych ułamków, więc na koniec zostawmy w wersji właśnie wielomianowej, czyli bez nawiasów. To nie znaczy, że ta pierwsza wersja jest zła, to też mówiłam, nie? Tylko po prostu jakby kwestia tak naprawdę zadania to trochę upraszcza. A w książce też jest różnie, jak tam sobie zerkacie, to raz jest, też zostawiają wielomian, raz zostawiają nawiasy, też bez takiej jakby większej zasady. Czyli można tak naprawdę, poprawnie jest i to, natomiast tak sobie ustaliliśmy, że na razie doprowadzamy na końcu do takiego wielomianu typowego, czyli właśnie takiej formy, gdzie nie ma nawiasów, nie? Dobra, czyli popatrzmy, że jak mamy ułamki, tak, z różnymi wielomianami i nie da się już tylko zmienić znakiem, tak jak tutaj, nie? No bo tutaj, no to myślę, że to jest jasne, no widać, że tylko wystarczy tego minusa dołożyć, czy tam wyciągnąć, natomiast tutaj no już nie da rady nic z minusem, tak? To nie jest zmiana, która nam pozwoli to zrobić, więc musimy po prostu powymnażać, tak jak przy rozszerzaniu ułamków zwykłych liczbowych. No i chodzi o to, żebyśmy dostali ten sam mianownik. Dobra, to weźmy sobie jeszcze jeden przykładzik z tego zadanka. Który tutaj? No, wszystkie są naprawdę identyczne, jeżeli chodzi o strukturę. No to weźmy sobie może D. Let's take D. X plus 1, 3x plus 1 minus 2 over 2 minus x. Right. Okay, so we have two different polynomials, right? We can straight away write the domain. So we have to get rid of -1/3 and 2, right? I hope you can see that. Why we have to get rid of negative 1/3 and 2. Okay, and now we want to get the same denominator. So the first one we multiply by 2 minus x, the bottom and the top. And the second fraction we multiply by 3x plus 1 and 3x plus 1. Okay, so what we get is 3x plus 1 times 2 minus x plus 1, 2 minus x. Okay, second fraction 2, 3x plus 1. And here we have 3x plus 1 times 2 minus x. Right. Okay, so now we can put this into one big fraction. Okay, and let's multiply here at the top. So it's x times 2 is 2x minus x squared plus 2 minus x. And here we have minus 6x minus 2. Okay, and at the end we get minus x squared. Then it's 2x minus x minus 6x. 2 minus 7 is minus 5x. And 2 minus 2. So they cross out, that's it. And we have 3x plus 1, 2 minus x. Okay, and that's basically the end. We could leave it like this, right? So leave with brackets. But if we want to get polynomial, then we should multiply the brackets. So let's multiply them. It's 6x minus 3x squared plus 2 minus x. And the last thing to do is minus 3x squared plus 5x plus 2. Okay, and that's the end. So we could easily leave it here, right? Leave it here because it's correct. But we want to have polynomials in the top and in the bottom, so we just multiply them. But it's not like necessary. Okay, let me check the answer. D, is it correct? D, 3, x plus 1. Yeah. Okay. Right. Any questions? It shouldn't be anything more difficult. And we have 10 more minutes, so I want to go back to 6.32 just to finish it off with this exercise. It's a bit different because we have, if you look there, we have examples where you have a number and a fraction, and they want us to add them together. So at first look, it might seem a bit different, like what are we supposed to do here? But it's not that difficult. So we have number like 3, and we want to add a fraction, algebraic fraction. Okay, so what do you think? How we can on earth just do it? How can we add number with algebraic fraction? Is it even possible that we can somehow add them together? I will just write the name here because that's easy. We have to get rid of just -1, so that's very easy. Okay, and what can we do here? Unfortunately, if some of you think that we could write 3 and 2x plus 1, unfortunately we cannot do that, right? Because this is a very weird structure. It's not an algebraic fraction, it's not a number, so no, it does not look good. So what we have to do, well, we have to get the same, again, the same denominator. So I can write 3 as 3 over 1, right? So it's very easy to get the same denominator. All I have to do is to multiply the first fraction, so expand the first fraction by x plus 1. And then we have 3x plus 1 by x plus 1 and plus 2x plus 1. And there you go. Now we have the same denominator, so we can put them together, and it's 3x plus 3 plus 2, and we get 3x plus 5 over x plus 1. And that's it. This is how we do it. So we have to change, kind of change the number into the fraction, algebraic fraction, right? But that's nothing difficult. You just have to multiply the numerator and denominator by the same polynomial. Now that's basically all you have to do. Okay, so one more just to finish off. Okay, let's take something with minus. I will take e. 4 over 2 minus x minus 2/5, right? So domain, let's get rid of 2. Sorry, 2. 2 minus 2 is 0, so we don't want to have 0. Right, and we are doing exactly the same. So 4, 2 minus x, minus, and now 2 and 5, and both we multiply by 2 minus x. Right? But here we have to do one more thing, because here we have 5, and here we had 1. So because it's 5 here, so it's not 1, we have to also, the first fraction, multiply by 5, just to get exactly the same denominator, right? Because we need to have exactly the same. Right, and now we have the same denominator, so we have 5 times 2 minus x, here we have 20, here we have minus 4 plus 2x, so it's going to be 2x plus 16 by 5, 2 minus x, and we multiply, so it's 2x plus 16 over minus 5x plus 10. Okay, let's check the answer, if it's correct. 632 e 2x plus 16, 10 minus 5x. Alright, it's correct. It's good. Right, I think we're going to finish with this one, because we have done quite a lot of examples. I hope you get the idea how we add and subtract algebraic fractions. Of course, these are not all examples that we're going to do, because what we did today, we add fractions with numbers, we add fractions with polynomials almost the same, just with different signs, and we add fractions with different polynomials, but just very simple ones that we could just multiply and get the same one. But this is like the first kind of examples that we always do with adding fractions. But next week we will go to a bit more complicated examples where we will need factorize more polynomials. But it will be time for this next week. Dobra, no to słuchajcie, nagadałam się. Mam nadzieję, że po angielsku też się udało zrozumieć. To chyba to w matmie to nie jest tak trudno się jakby połapać. Czyli tutaj przeszliśmy sobie takie 4. Tu się cofam, żebyśmy sobie jeszcze spojrzeli na koniec. Czyli tak, z liczbami, tak? Przerobiliśmy sobie z liczbami. no to są bardzo proste rzeczy, żeby mieć wspólny mianownik liczbowy. Potem pojawiły nam się, już tutaj mamy wielomiany bardzo podobne, jeden tylko nam wyskakiwał z minusem, więc wystarczyło tylko sobie przerobić z minusem. No i te ostatnie, no to mamy już dwa absolutnie różne wielomiany. No i metoda jest taka, że sobie mnożymy, tak? Pierwszy ułamek przez ten drugi wielomian, drugi ułamek przez pierwszy wielomian. No i na koniec z tą liczbą. Natomiast w przyszłym tygodniu, jeszcze przed świętami, sobie właśnie weźmiemy tutaj, dalej mamy trochę trudniejsze przykłady, no trochę ich zrobimy. To są oczywiście takie bazowe, te pierwsze. No te trudniejsze się wiążą z tym, że po prostu będzie trochę więcej, tam te wielomiany będą bardziej złożone, bardziej trzeba będzie tam je jeszcze porozkładać. Ale to w przyszłym tygodniu. Sporo przykładów zostawiałam, bo robiliśmy sobie po 2, więc też zostawiam Wam te przykłady do poćwiczenia, jak tutaj ktoś tam będzie chciał. No i tyle, słuchajcie. Ja czekam na pracę Antka i Krystiana. To dzisiaj bardzo proszę, tak? Do dzisiaj jest termin. A reszcie dziękuję i słyszymy się w poniedziałek. Dzięki, do widzenia. No i ze Staszkiem, tak, do zobaczenia Staszku, właśnie, żebyś nie pomyślał, że się z tobą żegnam. Dobra, do zobaczenia później. Dzięki.